Good evening, dear students. So today we will discuss organic paper of CBSE Chemistry exam class 12. Okay, so let's start. Question 1. First, write the structures and IUPAC name of the product expected from the following reaction. Okay, at first the reaction here given that a reaction of methanol with CH3 whole 2 CH MgBr followed by hydrolysis. So this is an Grignard reagent and this is the electrophilic center. So this Grignard reagent will attack to this electrophilic center, and here we will at first give an adduct, then on hydrolysis it gives primary alcohol. Okay, 2-methyl propanol. Next, reaction of phenol with concentrated HNO3. Hence, as their OH group is present, so the lone pair of oxygen is resonance with the benzene ring. Hence, ortho and para positions are electronically rich. So here, in both ortho and para position, the NO2 group is attached. So the product is 2,4,6 trinitrophenol. Okay, next question 22. How are carbohydrates stored in animal body? Mention any one organ where they are present. Carbohydrates are stored in body as glycogen and they stored in liver, muscle, etc. What is the basic structural difference between starch and cellulose? In starch, here glucose units are connected via alpha linkage, but in cellulose they are connected via beta linkage. Okay, let's differentiate between peptide linkage and glycosidic linkage. So peptide linkage is the linkage that formed between two monosaccharide, and glycosidic linkage is formed between two different amino acid. Okay, here glycosidic linkage represented by that is COC. Okay, ether linkage, and this is amide linkage CONH. Okay, and it present in carbohydrate, it present in protein. Next, nucleoside and nucleotide. Okay, so nucleoside is composed of only a nitrogenous base and a phosphate group, but nucleotides are composed of base, sugar, and phosphate group. Here, it is the precursor of nucleotide and it is the precursor of polynucleotide, DNA, RNA, etc. Okay, next, give reason for the following. First one is carboxylic carbon is less electrophilic than carbonyl carbon of aldehyde and ketone, because in carboxylic acid the group is this carboxylic group C double bond OH. Okay, you can release hydrogen and carboxylate anion is formed, then you can show the resonance, but I just show it in presence of hydrogen. Okay, so here that's which lone pair of OH group is resonance with C double bond O, that is carbonyl group, and so here this carbon is electronically rich, and so the electrophilicity is less in carboxylic group. So here the all description I can write. In case of carbonyl carbon which attached to OH group, so here resonance occurred between between lone pair of oxygen of OH group and the carbonyl group, hence delta positive charge of carbon somehow less. Okay, so it is less electrophilic than ketone and aldehyde. Next, propanol is more reactive than propanone towards addition of HCN. The addition of HCN is an nucleophilic addition reaction. Okay, in the electrophilic center. Okay, so here as the higher the electrophilicity of this carbon, higher will be the rate of reaction. Okay, but here in case of propanol, that is only CH3 group, one CH3 group is present, but in this case two CH3 group present. Okay, and CH3 group have plus I effect. So in this case this carbon is less electrophilic in nature, so the reaction here less reactive, and here more reactive. Okay, the description is given in this here. Next, write the chemical equation involved in the following reaction: carbylamine reaction and Gabriel-Thalamide synthesis. Let's see here chemical equation. Okay, so in carbylamine reaction, we know that an primary amine or aliphatic aromatic amine that gives isocyanide. Okay, and here the reagent is CHCl3, that is chloroform, and KOH. Okay, as there in ask that the chemical equation, so you can write in this type. Okay, next Gabriel thalamide synthesis. We know that the Gabriel thalamide and KOH is present in this reaction. Okay, so in alkylated, at first we can here we write this in alkylated thalamide. Next, if hydrolysis this part by KOH, then give and potassium salt of phthalic acid and primary amine. Okay, next give reason for the following. That is, first one is aquatic animals are more comfortable in cold water in comparison to warm water. We know that in cold water the presence of oxygen is more. Okay, so here they are comfortable, but we know that solubility of oxygen like gases decreases with increase in temperature. Hence, for respiration of these animals, they have not sufficient energy in warm water. Okay, so in cold water they are comfortable. Sprinkling of salt helps in clearing the snow covered roads in hilly areas because it helps the decreasing of freezing point of water on the surface of snow and helps the snow to melt. Okay, and clearing the snow from the road. Next, write the mechanism for the following reaction. That is, it is an elimination reaction. Okay, at first here given H plus, so the lone pair of oxygen at first attract to the H plus proton, and then OH2 plus is formed, and here this is eliminated as water. Next step, the hydrogen is lost from this and we give an alkene. Next, write the equation of the reaction for the preparation of phenol from cumin. In cumin, that is isopropyl benzene, if we added oxygen, that is formed this type of adduct, and then dilute H2SO4 if we added, then phenol and acetone is formed. Okay. Next, write the structure of ABC in the following reaction. At first, benzoic acid, when NH3 and heat is given, then formed amide, benzamide, and then Br2NaOH is if added, that is Hofmann degradation, then amide to amine, that is aniline, then NaNO2HCl 0 degree centigrade, that is diazonium salt is formed. Okay, benzene diazonium chloride. Next, CH3CH2Br, that is ethyl bromide. If we added KCN, then ethyl nitrile is formed, and then LiAlH4 if we added, then this will reduce to CH2NH2 and propyl amine is formed. If we added HNO2, that is NaNO2HCl 0 degree centigrade, then amine to primary alcohol is formed, because here the diazonium salt is not stable, that is unstable, but here in case of aromatic this is stable. Okay. Next, how will you convert the following aniline to parabromoaniline? Here in this case, as the lone pair of nitrogen is resonance with this ring, so orthopara positions are electronically rich. If we added direct beer to water, then in 3 position the bromine is attached. But if we at first we acylated the NH2 group, then acetonide form, and then beer to water if we given, then ortho and para both are formed, but we get separation this, and para product is separated out, and then dilute HCl is if we added this, then parabromoaniline is formed. Okay. Next, ethanoic acid to methanamine. Okay, so here ethanoic acid when heated with ammonia and heat, then CH3CONH2, that is acetamide is formed, then Br2 alcoholic KOH is given, then CH3NH2 methanamine is formed. Okay. Next, butane nitrile to 1-aminobutane, that is the formula of butane nitrile, and if we hydrolysis this, the CN group is produced to COOH. Okay. Next step, NH3 heat is given, then CONH2 is formed, then Br2 alcoholic, that is Hofmann degradation, CONH2 to NH2 is formed. That is 1 amino butane. Okay. Next, write the structure of product when D-glucose reacts with the following. That is HI. If we HI added in the glucose, then N-hexane is formed. Okay. Next, concentrated HNO3, that is more oxidizing agent. So here CHO and CH2OH both group are oxidized. That is saccharic acid. Next, Br2 water, that is weak oxidizing agent. If we given, then only CHO group is oxidized, but CH2OH is not. Hence, it is formed gluconic acid. That is the formula this. Okay. Next, if we added HCN, that is cyanohydrin is produced, glucose cyanohydrin. Okay. Next, what happens when bromobenzene is treated with magnesium in presence of dry ether? If we added magnesium in dry ether, that is bromobenzene, then the Grignard reagent, that is phenyl magnesium bromide, is produced. Next, which compound is in each of the following pairs will react faster in SN1 reaction? We know that SN1 reaction faster in this case, that is if the carbocation is stable via resonance, okay, or the tertiary carbocation is formed. Okay, so here in the first case, that is here allylic carbocation is formed, so it is stable via resonance, the double bond, and so here the SN1 reaction is faster. And in the next case, that is an tertiary halide, that is here formed tertiary carbocation. Okay, so here SN1 reaction is faster. Next, write the equation for the preparation of 1 iodobutane from 1 chlorobutane. That is, first is Finkelstein reaction. The reagent is dry acetone. Okay, and NaI, sodium iodide. That is the product. Okay, next step, but1-in. But1-in, that is the reagent is NaI, sodium iodide, and acetone. Here the product is this. Next, write the structure of major product in each of the following. At first, that is this reagent is here given, and KOH, that is in presence of ethanol. Okay, so ethanolic KOH if we given, then elimination reaction is occurred. But if here added aqueous KOH, then substitution is occurred. So here eliminated product is major product, that is propene. Okay, next, that is chlorobenzene and acid chloride. If we added in presence of anhydride AlCl, that is Fiedel-Crafts acylation reaction, and here the para product is major. Okay, so parachloro acetophenone is formed. Next, an organic compound having molecular formula C5H10O can show various properties depending on its structure. Draw each of the structure if it. Okay, give positive iodoform test, shows Cannizzaro reaction, reduce tolerance reagent, and has a chiral carbon. Okay, so here that is one mistake in this molecular formula. Here, so from this data, we can conclude that the molecular formula is C5H10O2. Okay, and if we taken this molecular formula, then all the data are matched with this, and the structure I can conclude that is a beta hydroxy ketone. Okay, sorry, alpha hydroxy ketone. If we taken this molecular formula, the dB calculation is that 5 plus 1 minus 10 by 2, that is 1 double bond is present in this case. And first at first that it gives positive iodoform test. So the iodoform test, if positive test is given, then it have the ketomethyl group present. Next says that it gives Cannizzaro reaction. So if Cannizzaro reaction is given, then it have no alpha hydrogen. Okay, and next it reduces tolerance reagent, hence it have also CHO group, and it has one chiral carbon. Okay, these are the data. So the structure is an alpha hydroxy ketone. Okay, the reactions are, you can see that if we given that R form reagent, that is I2NaOH, then in this presence of this group COCH3, that is a ketomethyl group here present, that so it gives R form test, positive test. And as it is an alpha hydroxy ketone, so it gives tolerance test positive. Okay, and if we tautomerize this alpha hydroxy ketone, then it forms here no alpha hydrogen is present, so it gives Kanizer reaction. Okay, so here the molecular formula of this compound is this, that is this CH3CO CHOH CH2 CH3. Okay, next write the reaction involved in the following. That is, first one is Wolff-Kishner reduction, that is, and next one is Hill-Woollard-Zelenowski reaction. So here first Wolff-Kishner reduction, that is, if we here I give an example, but you can write an ketone or aldehyde. That is, if we added NH2, that is hydrogen, then and that is water is lost, and that hydrogen product is formed. Next, if we give KOH heat and ethylene glycol, then here an alkene is formed. Okay, that is here in the Wolff-Kishner reduction, that is CO group is converted to methylene group. Okay, CH2 group. Next, Hill-Woollard-Zelenowski, that is if we take an acid, that is CH3COOH, acetic acid, and here the reagent is paired to red phosphorus and water, so alpha bromo acid is formed. Okay, next, how can you convert each of the following compounds to benzoic acid? That is acetophenone, ethyl benzene, and bromobenzene. At first, we taken as acetophenone. Acetophenone, if we give iodoform test I2NaOH, then iodoform is produced and sodium salt of benzoic acid. Then, if we given a dilute HCl, then benzoic acid is formed. Next, ethyl benzene, if we oxidized this in presence of KMnO4H plus, this CH2CH3 is oxidized to COOH. Okay, then benzoic acid is formed. Next, if we added bromobenzene in magnesium diether, then phenyl magnesium bromide is formed. If we added CO2, then the electrophilic addition, nucleophilic addition takes place here, and benzoic acid is formed. Okay, next, arrange the following compounds in increasing order of their property is as indicated. Here all the properties, all the groups are carboxylic acids, but here the group attaches NO2, here fluorine, and here CN. We know that electron withdrawing property, withdrawing nature, that is at first NO2, it has a minus I and minus R effect, and next CN, next fluorine. Okay, so the order of acidity, we know that electron withdrawing group is where the present, then it is proportional to strong acid. Okay, strong acid, so we know here we can say that is where the NO2 group is attached, that is most acidic, then CN, then fluorine. Okay, so here we can write this A, get A less than B less than C. Next, ethanol, propanol, and butanone, propanone, the reactivity in nucleophilic addition reaction. We know that in the carbonyl carbon, where the electrophilic center is more reactive, their nucleophilic addition is more facile. Okay, so in the case of CH3CHO, that is ethanol, it is more reactive than propanol, then propanone, then butanone. Okay, so here the order is C less than D less than B less than A. Okay, so thank you.